Good morning, good evening, good afternoon, wherever you may be watching this from. This is Kamias Binda with another segment under vectors. The angle a vector makes with the x-axis. This is the next segment. So you can be asked to find the angle that a certain vector makes with the x-axis. We can have an example of this. A point R, which can be -3. Okay, let's not do that. Let's just write the coordinates. This is 1, 2, 3. 1, 2, 3. 1, 2, 3. Then 1, 2, 3. -3, -2, -1, -1, -2, -3. Then we have 1, 2, 3. 1, 2, 3. This is the y-axis. This is the x-axis. Now, we can have a point here, which is R. Let's put it here. R. Then we have a vector. R is at 3, 3. Then we're told to, and we're asked, what is the angle that this vector makes with the x-axis? So we are told to find the theta. Theta, that is here. So we're told to find that theta. What should we do in this case? This vector, and we are told to find the theta that is there. If it's not visible, let's use the black one. So I'm told to find that theta. The first thing to do is you form a triangle. You form a triangle. So the vector is going from there, it's going like that. Alright, sorry, the coordinates was -3, 3. So you complete the triangle like that. Such that you form a 90-degree triangle like that. And then step 2 is we use tangent of theta. So tangent of theta is equal to opposite over the adjacent side. Tangent of theta is equal to, so we are looking for this theta. The opposite side is 3 because it's 1, 2, 3. It is 3. You divide by the adjacent. Adjacent where the theta is -3. -3. Theta is equal to tangent inverse of 3 divided by 3. So in this case, which is just the same as saying tangent inverse of 1. So let's say theta is equal to tangent inverse of 1. Now in this case, we are ignoring this negative when finding the inverse, because we'll now come and consider this will be the associate acute angle found in the first quadrant, but since there's a negative, we'll come and consider it later. So theta is equal to tangent inverse of 1, 45 degrees. It's a special angle because tan 45 is 1. And then from after finding theta as 45 degrees, this is the angle in the first quadrant. we'll go on now to find the theta that they are looking for. So the x-axis, let's start, for example, let's remove this x-axis. Let's think of this as 0 degrees as a quadrant. 90 degrees, 180 degrees, 270 degrees, and then we are back 360 degrees. So since our sense is 0 degrees, our reference point, the angle that we are looking for is where from here going to there. This is the actual angle in question. So from the x-axis there, 0 degrees, here is 90 degrees, there. We're looking for an obtuse angle in between 180 degrees and 90 degrees. That is what we are looking for. So it means that our theta will be equal to 180 degrees minus 45 degrees. This is equal to 135 degrees. This is our final answer. This is the angle that this particular vector in question makes with the x-axis. Now, if anyone is confused there, this theta, the theta that we're talking about, is actually, let me say it like this. The theta we find here is to find the angle starting from here to there. So we use the trigonometric ratios to find theta. Then we take note of the sign. That sign will tell us which quadrant. The fourth quadrant would have given us a reflex angle, so we do not consider that. It means that the angle is starting from here, the reference point 0 degrees, in between 180 to 90 degrees. And that is it for this video. This has been Konas to be now. Another segment of videos, and bye-bye.